All right, so if you've ever built a machine learning model, you totally know this feeling. You've spent forever tuning it, your accuracy looks amazing, it's like magic right there in your notebook. But then comes that moment of truth. You're probably thinking, phew, the hard part's over. You've wrangled the data, you've trained the algorithm, and the results look fantastic. But here's the thing, and it's a big one. Getting a model to work in a notebook is one thing, but turning it into something that actually creates value out there in the real world, that, my friends, is a whole different ballgame. Yeah, I mean, proving a concept in a nice, clean, controlled environment, that's one thing. But getting it to work reliably, day in and day out, in a messy, live production system, that is a completely different beast. And that's the gap we're talking about. The one that separates a cool science project from a tool that actually makes a difference. Okay, so to make this super clear, let's stop talking in abstracts, let's get concrete. We're going to step inside a smart factory and see what a real-world machine learning system actually looks like when it's on the job. So, picture this, a super fast assembly line just pumping out thousands of new phones every single hour. Our job? Quality control. We're using a computer vision model to spot tiny, microscopic scratches that a human eye would just never catch. I mean, this is the perfect job for machine learning, right? So how does this actually work? Well, it's not just the model sitting there by itself. It's a whole system. First, a camera snaps a picture of the phone. Then, that image gets sent through an API to a server. On that server, our model does its thing and analyzes the image. It sends back a super simple answer, defect or no defect. And based on that answer, a decision is made right there on the factory line. See? The model is just one piece of this whole puzzle. All right, so you've built this amazing system. It's running smoothly, it's catching defects, everything is perfect. What could possibly go wrong? Well, you know the real world. It's messy, it's unpredictable. This is what could go wrong. Think about it. Your model was trained on these beautiful, perfectly lit studio-quality images. But then, reality hits. Maybe the maintenance team comes in and changes the overhead lights, and all of a sudden, the images coming in are way darker, the shadows are all wrong, and your model, which was working so perfectly, it has no idea what it's looking at. And just like that, its performance starts to crater. This exact problem has a name. It's called data drift, and it's a massive challenge in machine learning. It's what happens when the live real-world data starts to change and no longer looks like the clean data you trained the model on. And when that happens, you just can't trust your model's predictions anymore. And this right here brings us to maybe the single most important and honestly the most overlooked truth of putting machine learning into production. You know that model, the one you spent weeks, maybe even months perfecting? Well, it's just the tip of the iceberg. And here it is. This might actually shock you. In a lot of production ML systems, the actual model code, the algorithm, can be as little as 5% of the entire project. 5%. The other 95%? That's all the infrastructure, all the plumbing that has to be built around it just to make it work. This huge difference is what engineers call the proof of concept to production gap. And believe me, it is not a small gap. Closing it, going from that perfect little notebook to a system that can handle the real world, is a massive, massive job. It can seriously take months and months of hard engineering work. So you're probably asking, what on earth is in that other 95%? Well, it's all the stuff that's not glamorous, but it is absolutely essential. We're talking about data collection systems, data verification to make sure garbage isn't getting in, feature extraction pipelines. It's the monitoring tools, the analysis tools, the APIs, and the serving infrastructure that has to be rock solid. And think about it, those monitoring systems, they're the things that would have told you immediately that the factory lights changed. It's basically a hidden factory running behind your model. Once you see this, it completely changes how you have to think about machine learning. The focus has to shift. It's not just about building a model anymore. It's about building an entire system. It's a totally different mindset. So here's the bottom line. Success isn't defined by who has the best model accuracy in a notebook. Real success comes from engineering the entire system around it, from the moment you collect the data, to training, to deploying it, and then monitoring and maintaining it over time. You have to own the whole life cycle. And this idea completely redefines the job of a machine learning engineer. It's so much more than just writing algorithms and tweaking hyperparameters. There's a great quote from Andrew Ng that just nails it. He says, "Our job is to make these things work." It's about taking ownership of the whole problem. So when the data drifts, you can't just throw up your hands and say, "Oh, that's not an ML problem. It is your problem."
It's our job to build systems that can handle the real world, the world as it is, not the perfect world we wish we had.
All right, so let's wrap this up with the key takeaways. Number 1, training a model is just the first step. It's the starting line, not the finish line. Number 2, real-world data is always changing. You have to expect data drift. 3, your ML code is probably a tiny, tiny piece of the whole puzzle. And finally, real success means engineering the entire system, from start to finish. So I'll leave you with this final thought. The next time you build a model, don't just stop when you get a good accuracy score. Ask yourself, how am I going to engineer the complete system around this? How will I make it robust enough to survive and deliver real value out there in the messy, unpredictable real world?